Hello. So we will be practicing some total heat uh, or Q equal to MCAT problems today. Okay, let's start with question one. A 15.75 gram piece of iron absorbs 1086.75 joules of heat energy, and its temperature changes from 25 degrees Celsius and 1 to 175 degrees Celsius. Now, calculate the specific heat capacity of iron. So before we start, I'm just going to write down all of the conversions and the formula for total heat. So let me also write some delta T and delta H. So delta H, oh shoot, okay. Delta H is known as enthalpy, and enthalpy is also known as molar heat. I don't think we need to know that for this, but I'm just writing it down. Now, delta T is something that we need to know. Delta T is change in temperature. Change in temperature. And since delta T, so delta is change. So change in T is change in temperature. Now, Q denotes total heat. And total heat is equal to MCAT, or M times C times delta T. Now, what is M, you may ask? M is the mass, and C is the specific heat capacity, which is usually in the units of joules per grams times Celsius, or K over grams times Celsius, and K is Kelvin, so just for your own knowledge. So now that we have that in mind, let's start our first question. Oh, sorry, I forgot about the conversions. So 1 calorie is equal to 4.18 joules, and 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules. Okay, now let's start our first question. Sorry about that. So we are given our mass, and this is our M. So let's write it down. M is equal to 15.75 grams. Now, this is our total heat, and our total heat is denoted as Q. So Q is equal to 1086.75 joules of heat energy, and temperature changes from 25 degrees Celsius to 175 degrees Celsius. So this change is a positive change of 150 degrees Celsius, in written in two sigfigs. So let's also write these things down. Q is equal to 1086.75 joules, and delta T is equal to 150 degrees Celsius positive. Now, we're wanting to find specific heat capacity, which is denoted as Q. No, sorry, C, which is denoted as C, sorry, which is specific heat capacity. So, if we're wanting to find C in the equation Q is equal to MCAT, then we bring all of the known units to one side, while we have C on the other. So C is equal to Q divided by M delta T. Now, we're given all of these units over here. So we can just plug them in really. So C is equal to 15.75 grams over mass, which is 15.75 grams, times 150 degrees Celsius change of temperature. Now, let me bring out my calculator. So, 15.75. Let me actually get, yeah. Oh, shoot. Uh, I wrote my Q wrong. This is supposed to be, this is supposed to be 1086.75 joules. Sorry about that. 1086.75 joules. So 1086.75 over 15. Okay, let me do this again. 15.75 times 150. Let me just write this value down. 2362.5. Now we can officially divide. 1086.75 over 2362.5 is 0.46. So 0.46. Now we definitely need units. So we have joules over grams times Celsius. So that's all we need to write. Joules over grams times Celsius. So now that we divided, we need to know the significant figures rules. So in division, it's always the least amount of sig figs. So here, the most amount of sig figs is 6, while the least is 2 because there's a trailing 0. So we always have to stick to 2 sig figs as given here. So now that we have that in mind, we this is already rounded, so we already have our answer. This is rounded to 2 sig figs. So that's our answer. Now let's move on. This should get easier over time. Okay, how many joules of heat are needed to raise the... Okay, how many joules of heat? We already know that Q is in question. Are needed to raise the temperature of 10 grams of, which is mass, of aluminum from 22 degrees Celsius to 55 degrees Celsius, which is a positive change or positive 33 degrees Celsius or delta T. If the specific heat of aluminum is zero point 0.9 joules over grams times Celsius. So this is our C. So let's write all of this down. Q is in question. Let me just rewrite that. Q is in question. M is equal to 10 grams, 10.0 grams. We need to know that because we need to always round to sig figs. And C is equal to this, 0.9 joules over grams times Celsius. Delta T is equal to 33, positive 33 degrees Celsius. Now, we can, since Q is in question, we can just use the Q is equal to MCAT equation. Now we just plug in the values. Q is equal to 10.0 grams times 0.9 joules over grams times Celsius times 33 degrees Celsius. So I already see that the units cut out. So G, G, C, C, they already cut out. So what we're left with is 10 times 0.9 times 33. So 0.9 times 10 is 9, and 33 times 9 is 297. So now that we have that, 297.0, I believe, right? So let me just put this in the calculator. For sig figs, 0.9 times 33, 297. So the total heat is 297 joules. And let's revert back to our calculations. Since this is division, it's the least number of sig figs. So the least number of sig figs is one sig fig. So that means we need to round to 300 joules. Let me check my answer key to see if I'm right. Yes, I am right, but I am supposed to write in scientific notation, which I haven't been doing. So 3.0 times 10 to the 2 joules. And that's it. Now, now calculate the specific heat capacity of a piece of wood if 1500.0 Gs of the wood observes 67,500 joules of heat and its temperature changes from 32 degrees Celsius to 57 degrees Celsius. Okay, so we are wanting to know C. C is in question. And we know mass, so let's write that down. M is equal to 1500.0. Remember, every single digit counts because we need to round to sig figs. Absorbs 67,500 joules of heat. So we know Q. Q is equal to 67,500 joules. And temperature changes positively from 32 degrees Celsius to 57. So delta T is 25, positive 25 degrees Celsius. And we do not know C. C is in question. So since C is in question, we can use the general formula C is equal to Q over M delta T. Now plugging in the values, C is equal to 1500.0 grams over 65, no, sorry, over, oh, I messed it up again, sorry. 67,500 joules over 1500.0 grams times 25 degrees Celsius. Now, if I plug that into a calculator, I get 1500 times 25, 37,500. So 67,500 over 37,500, which is 1.8. 1.8 joules over grams times centigrade. Now we need to round to nearest sig fig. So this is 3 sig figs, this is 4, and this is 2. So we need to round to 2 sig figs, and it's already rounded to 2 sig figs. So that is the answer. Let's check, and we are correct. Awesome. So let's continue on with our last question. 100 grams of 4 degrees Celsius water, or actually, let's do another question just for the sake of science. 100 grams of 4.0 centigrade water. So this is mass, okay? And this this is the initial temperature. Temperature initial. So 100 grams of 4 degrees centigrade water is heated until its temperature is 37 degrees Celsius. So this is temperature final. Calculate the amount of heat energy that is needed to cause this rise in temperature. So we do not know how many joules of heat, which is going to be our Q. And if we do T final minus T initial equal to delta T, then we're going to get 37 minus 4.0 centigrade, which is 33. So our delta T is 33 degrees centigrade. And that's positive because initial is lower than the final. So we can write that down. Mass is equal to 100.0 grams. C, we do not know C. So this is where our knowledge comes in. As we previously discussed, the specific heat capacity of water is 4.18. Oh, we did not discuss this. Okay. So an easier way to remember the specific heat capacity of water is that you can just use the calorie to joule uh, conversion, which is 4.18. So the specific heat capacity of water is also, let me just write down, C water equal to 4.18, which is the same as the conversion, joules over grams times centigrade. Okay, so now that we know that, this is always the same, by the way. Specific heat capacity is always the same in a substance. Okay, so now that we have that in mind, the C here is going to be 4.18 joules over grams times centigrade. And our delta T, as we discussed, is 33 degrees Celsius. Now we have MCAT, and if we remember, Q is equal to MCAT. So if we plug in, Q is equal to 100 grams times 4.18 joules over grams times centigrade times delta T, which is 33 degrees Celsius. All of the units cut out once again to get us 418 times 33, 418 times 33, which is 13,794 joules. Or if we round it to sig figs, it's going to be 1.38 times 10 to the 4th joules. And let's see if we're doing it right. So the least number of sig figs is 2 sig figs. So no, it is not right. We need to change the significand to 1.4 because that is 2 sig figs. So the final answer is 1.4 times 10 to the 4 joules. Now let's see if that's right. Correct. So they didn't write it in significant figures, but I just took the extra step. The